My name is Gary Morin. I'm the Technical Director here at Keynetix, and we'll introduce a little bit more about Keynetix and who we are later on in the presentation. What I really want to start kicking off with is really talking a little bit about BIM. I'm sure that most people now on the line here will be hearing about BIM left, right and centre, to people talking about BIM. There's initiatives throughout the whole world, in the UK, Australia, in the US, I guess in almost every state, all looking at and ways of driving BIM forward. And really, whenever you do that nowadays, like originally BIM was primarily aimed at buildings or vertical BIM, if you like. Nowadays, it's moving more and more over into infrastructure, into roads. But whenever we tend to look at a BIM model, one that's an output from BIM, it always looks like this. We have some piles in there, the whole building, but generally speaking, they have this habit of floating in space. The ground is missed from it, the subsurface, the geology is missing from it. And there's various reasons why that happens. One is, yes, it's not, you can't see quite so much if you've got all the geology there. But part of the reason is how geotechnics and geology is often viewed in the overall design process. It's fair to say that it is a very traditional process for a lot of people. A site investigation or ground investigation will quite often be seen just as a tick box at the very start of a project. We have to have a ground investigation done, so let's get it done as cheap as we possibly can so we can get on now with the real work. I may be being a little bit pessimistic, a bit negative there, but quite often it is viewed just as an overhead and not part of the main construction project. However, there are consequences with taking that view. The images here are rather dramatic. Perhaps we want to ignore that, but I know that in surveys in the UK, and I think this pretty much holds out for the US as well, around 37% of projects that had major overruns cited ground conditions as a major contributing factor behind it. And primarily, at least for public projects in the UK, around 70% overrun or overspend. So we're talking about 30% of projects are saying that they are overrunning because of ground problems. Surely there's something we can do to actually mitigate against those and reduce the risk of those things to save money. And I believe by really applying BIM principles to geotechnics, then you can actually mitigate against some of those. You can never reduce all of them, but you can get rid of some of the problems. Roll that slide. So traditionally, the way geotechnics works is perhaps you have a site investigation done, the information will come back, and they will send you a piece of paper, a site plan with your boring logs on, and you have a whole series of boring logs being supplied to you. And then you as an engineer will look at a boring log and try to figure out where it is on your site plan, and in your head, visualize where this data all is. Now again, you've had loads of years of experience with this, so you're quite good at doing it, but as your projects get larger, you're looking at this data, it's harder and harder to visualize how it all goes together. Now, if you start using BIM principles and the idea of sharing data, quite often we have people saying, oh, we're sharing data, we sent the data electronically. It's a PDF report. That's not data, that's information. But if you're sharing data electronically, you are really sharing the true data behind it. Then you can start doing some sweet things. Play, thank you. So in this example, we're inside AutoCAD Civil 3D. We have a ground model, or perhaps we have an initial site plan of what we want on our site. Our drillers have been outside and the drill team have pulled back and generated some initial borehole data. We've not done really any interpretation. All they've done is sent the data back, which has been included into the central database. So this could actually be on the same day as the data has been drilled. But we now can access it and look at this data in context with our site. So here you can see our boreholes being shown on screen. We zoom out, put it into shaded view, and instantly we're looking at our boreholes. Instead of having lots of separate bits of log sheets and our site plan. We're trying to relate what's what. We're looking at the whole lot of the data in one go on screen. I can now, if I want to, just turn off the layers and start highlighting different parts of geology, different codes that we've found across the site. So it's highlighting anomalies where problems may be, and we're seeing them in conjunction with the data. So what we're doing is, by having the true data, it's actually transforming the way we can view this data and understand it from the traditional way. Now, I'm only just starting here. This is just a really quick glimpse to say, by having data, we can start doing things like this. But there's a lot more steps we need to be involved. Now, I'm sure that nearly everybody on this webinar have all seen this graph already. The graph which basically indicates you want to bring your decision making early on in the project. Traditionally, if we look at this data here now, you have this brown line which represents decision making, and primarily a lot of decisions have to be made at construction time. But when you find problems at construction times, it costs a lot more money to correct them. And also, you can't really influence your overall costs by much by that stage. You know, it's too late to make decisions. So the whole of BIM is primarily about bringing the decisions further on, making the decisions earlier on. That's why we have our digital prototypes. Now, if we actually look at this in conjunction with the geology, now the AGS in the UK, or the Association of Geographical Specialists, it's our sort of governing body in the UK, and this is one of the statements they give out on reasons for a thorough ground investigation. Early investigation allows the identification of any ground-related risks associated with the development so that they can be effectively managed and associated costs controlled. Isn't that the reason for doing BIM? You have your digital prototype, so you can do clash analysis, work out what's going on before you start building. It's the same reason why you need to do a thorough site investigation and have that information integrated with the rest of the work you're doing. It goes hand in hand with doing BIM. Now, what we've worked on in the UK is what we call our geotechnical data journey, or what we've worked on as at Keynetix is our geotechnical data journey. And this is how we view geotechnical BIM. If we look at it, at the heart of everything that we do is data. This is your data model. This is the model that you build up. But at the start of the project, you may want to prepare, work out what data you want to capture, what type of work you're going to do, where you're going to put your drill holes, and this is part of your desk study. Now, in doing this initial preparation, you'll actually want to use a lot of your old historic projects. Have you already worked in this area? Do we know about this area? Have you got any maps that you've got, geology maps, other site investigation reports? You want to use that information and prepare where and how you want to place your holes. In fact, actually, if you're only going out for tender stage, if you've already got projects and you can quickly get hold of the data that you've done in that area, it can actually help you be competitive against your competition, because you may already know what the ground conditions are like there. So you can get hold of that report and look at it very quickly. It gives you a big advantage. But once you've prepared your data, prepared your site investigation, you may want to then send it out and perhaps use field-based data capturing techniques, very rapid data entry to get it into your central database so you can start looking at it and analyzing what's going on. At any time you want to go out and send out scheduled test results. We actually do software, by the way, for managing geotechnical labs. You want to pull that data and have it all stored centrally. You're then going to go and analyze data, work out what's going on around your site, perhaps do your initial interpretation. Anytime you want to generate a report. Now, originally, we've been doing this for 20, 25 years. We had this as a linear process. You start with your preparation, you move into your investigation, then testing. But actually, with the advent of technology, with the advent of BIM, we realized this is a circular option. At the heart of it is your data. At any stage, that perhaps you do your initial site investigation, you're bringing data and you're analyzing it, but actually for phase 2 of the project, your initial data interpretation is going back in and being used to prepare the next phase of the site investigation. There's communications going on all around data journey from one side to the other, and it's no longer a linear process. It's all around managed central data, which you can use time and time again. And this is what we Keynetix specialize in. Just to give you a little bit of a picture of who we are, we're a UK-based company. We've actually been working in this field now for over 30 years, so we're not just sprung up in the last year or two, and we concentrate on geotechnical data management. We are Autodesk, what they call their AC industrial partner, and we're the only one for geotechnics around the world, so we're their go-to people, and we have developed for them in the past the Autodesk Geotechnical module. And if you watch that space, there'll hopefully be a new version coming out in the not-too-distant future. So we're their go-to people, and we basically develop a whole range of products, all covering different elements of geotechnical data management. We have been established in the UK for many years, and as you probably expect, over 25 of the top 30 consultant engineers in the UK all use their software, as well as a lot of environmental consultants. But about 3 or 4 years ago, we changed our tack and we developed our software from scratch again, suitable for a worldwide market, and this is now why we're working very closely with Microsol Resources in really making it available to you guys in the US. We believe we do have a really good product that can really help people manage geotechnical BIM and manage geotechnical data. Our client base, we deal with many large geotechnical consultants around the world: Mott MacDonald's, Cowley, MWH, Atkins, Jacobs, a whole range of companies. A lot of them I'm sure you'd recognize. So we're all about central data management, but if you're using central data management, your data model, what it allows you to do is very quickly generate plots and prints. So for instance, here we have site plans for where we're going to go out and drill our boreholes, do our borings. We can generate quick sections from the central data. We can generate boring logs at a single button click. We may want to analyze and start viewing data inside Excel. Again, it is something we can just do with a quick single click, or take it through into AutoCAD Civil 3D, where we want to visualize it together with our site plans and generate models from that data. We have 2 main areas of software. We have our KeyLab Geotechnical Lab Management software. So this is basically used to run a geotechnical lab. So as samples come in, they get barcoded, the barcodes get read, we can set up schedules, set up test equipment, report on all information. I'm not going to go into that today. But the other side is our geotechnical data management suite of software. It's primarily HoleBASE SI, which we have 2 flavors of, professional and standard. Professional has mapping in. You'll see some of the features of that in the presentation in a moment. It then has modules, so you can design all your boring logs or your site plan logs or your profiles. Your strip profiles are shown in AutoCAD Civil, can all be designed using the Template Studio. We have additional data entry modules which can be used on-site or on your desktop or laptop to get data rapidly into HoleBASE. And then we have our 2 extensions that work in both AutoCAD Civil 3D and in Microsoft Excel to make this data available in tools that people need to use and access it with. So let's go on and start giving a very quick demo. This is primarily a very fast overview of the type of technology and the functionality that we Keynetix develop and how you can use that to manage your geotechnical data. So this is HoleBASE SI. As we log in, it's fully secured, so each person as they log in will have access to different projects. So I've got my sort of a data grid here which we use in the system, and I can sort, I can filter on data to find just the information, just the existing projects in this case that we have available. So here, show me all my current open projects. Let's close that. This is now all of my projects. If I go and do a tender or we're doing a new desk study, I can go open up a map view, and we're using Microsoft Bing mapping as part of HoleBASE SI. We use an enterprise license, so you can use this for printing out and putting into reports. But I'm just going to use the go-to feature here and place name. And let's just imagine Microsol Resources want us to come along and look at redeveloping their office in New York. We've just zoomed to that location. Unfortunately, I have no projects in that area I've done work on, so I can't really help me. So to make this demo a little bit easier, let me log and move to somewhere where I do have projects. So let's go to Warsaw in the UK. So we just zoom to that area, and you can see my project dots on the map showing different projects that we've already done in this area. So I click on any, up pops a little tooltip so I can see a little bit about that information. Okay, here we have a project, aptly named test project for me to go in and look at. So this is a project we've done in the past. I can look at this data now and work out how relevant it is for me. So we now open this project up again. You can see we have a data grid. On the left-hand side, we have all the different types of data that we can store within HoleBASE. There's literally, I think, 2,500 different fields within the system. So here, what we've done in a matter of a couple of seconds is just looked at all of the strata we have across our old site. We can zoom to where it is on the map and see the individual borehole locations. If I want to, I can just generate a quick log strip, a quick boring log. So I'll just go and quick log. So we're using this old archive project that we've got to quickly understand what information we have available. So we can now go on and start working out the desk study for our next job. Oh, well, let's pretend we are now. Let's move on and say we are now doing the desk study. So I've got some boreholes placed. I'm now going to bring in some background mapping. So this is obviously in the UK, so I'm using some web mapping for the UK. But we could be bringing in US web-based mapping here in the background. And you can see here I've got my underlying geology. So I click on it, it's telling me what geology I have in that area. Perhaps I also want to bring in some imported XF or shape data. I've already imported these just for speed, but I'll click on here. And now we've got some site plan information come in. So I've got better context data. Just as a matter of interest, I've just brought in some shape forestry data. So it could be any form of data we're bringing in here, and we notice that we actually have some forestry information here. In this case, it's low density woodland, so I'm quite happy to drill holes in that area. So we could be using this now, planning where we want to put our holes, where we want to do it. We could have subsurface utility information in here, anything we want, but we can plan. And once we positioned where we want all our holes to be, we can go back to our location details here, export the information out, put it onto a GPS device, and go out and start drilling our holes in the right location. So that's one part of it, using our archive of data, using our existing projects, using GIS to work out where we want to actually do our drillings, what information do we want to gather. We now go on to the next stage, which is actually collecting the data. Now, we've been doing this, let's say, for a few years, and the one thing we found with collecting data, in the UK, we have a food called Marmite. I'm not sure whether you've heard of Marmite. It's a food which you either love or you hate. There's no in between. And we find that data logging is similar. Some people like data logging, some people like putting it on a sheet of paper. So what we basically say to people is there are devices out there. In the UK, we developed Key Logbook together with another company. We have HoleBASE SI data entry. You can use HoleBASE itself to do on-site data gathering. Or there's software like Data Forensics Plog you may want to use. You may just want to use Excel. What we say is use whichever tool you want to use, what you find best, that you find comfortable. However, what we will give you is 2 rules. You really only ever want to enter your data once. You don't want to keep re-entering your data for every different system. You generate far more errors and introduce problems by doing that. And if you can, capture it as close to source as you possibly can, i.e. at drilling time. In other words, get someone else to capture it for you. You can capture that data, and if you do it very early in the stage, you'll reduce errors, you reduce problems with it, and it means you can get it into the system and start using it very rapidly. And when it comes to BIM, if you can start sending back at the end of each day your drilling data back, you can start consuming that and using that information straight away. So let's just have a quick look at this now. So we're in our project, and if I wanted to, I could go to import data, and here we've got AGS formats that we use in some part of the world, or you could use CSV, Keylog book, the whole host. If you're using data entry, the data will already be on the system, but we can go through, import this data. For speed, I'm not going to do that at the moment, but you can see there's a multi-step wizard that you go through to qualify the data and bring it in. If we want to, we could use our data entry tools. And again, a really quick demo here. We've got all different types of data entry. These are all completely user configurable, so we can define different profiles. So this is a very simple 3-step profile for entering dynamic probe information. So we've picked a boring location. We've typed in some dynamic probe general information. I'm now typing in the records. So it's automatically picked up the next steps down. I've got down to 3.4 already. So 3.5, I type in my blow increments, 43, it automatically defaults to the right depth. I now jump to the next record. So it's designed to allow really rapid data entry of the information onto the system if you're not capturing it at source as such. At any time when you're entering data, you can just generate a quick log to make sure it all looks correct and everything, so that looks all okay, and I can carry on. Now, this particular profile is a really simple one. It's only got 3 simple steps. But if we go to something like trial pit, this is an 8-step wizard. So this particular one, we've got a whole host of different data we may want to type in. We could simplify it. We can design these to whatever your requirements are, only to enter the data you need to enter. So we have these tools to get the data in. Let's move on now. So this is a real whistle-stop tour. But on the left-hand side, we have all these different placeholders where we can store a whole host of different data. And again, this can be configured to your own particular requirements, but we like not to reinvent the wheel for every customer. Let's all have standard way of working for all our projects, and it means you can make much better use of it. But here we're saying, let's look at all data, or only just look at data in a particular part of the zone of your project. North zone, south zone, phase 1, phase 2. But at the moment, I'm looking at all of our data. So I'm just coming down here to in situ, some in situ tests, and our standard penetration tests, i.e. our blow counts. So we have our AND values that are calculated and being shown here. And we've also got them color-coded. So we're just looking at here again, another way of looking at and viewing your data and analyzing it. So perhaps here, I'm interested on where we've got soft ground. So by just grouping them really quickly like this, we've got 3 soft ground values. There they are. We can look at them. Now this coding banding, as we've got it, we call them trigger sets. Normally we use it for environmental data. So show me where arsenic values are greater than X, Y, Z or whatever. In this case, I've just used it for SPT, but actually you could use it for anything. Liquid limits, plastic limits, anything you want. You could use these as a way of banding your data to highlight where you may have problems across your site. Another technique we've got to analyze, look at the data, is what we call our report views. This is where we group a lot of data in all different tables together. So here I've just picked on a grouping for samples and geology. So this is all my samples across all my geology. So if I just come here and say, actually, I'm only interested in samples in peat, so straight away, I've now got my samples in peat across the whole of my site. I now come here and say, actually, I'm not interested in all my samples. I'm only interested in undisturbed samples because I want to do some scheduling of some tests on that for these ones. So I've now got 5 or 6 undisturbed samples across my whole site, which I've quickly narrowed down. I'm going to save that now, and when I save it, I can save it so other users of the system can access it, or they can be saved and viewed on the map. So I save that, close that all down. If I was a new user coming onto the system now, I just pick on my peak use samples, and I'm straight away in with that data, looking at that information. If I want to see it on a quick log, we've just generated an on-the-fly log there. There's my peak color-coded in, and these views represent my undisturbed samples. So instantly we got hold of that information. If I want to look where my undisturbed samples are on the plan, I'll come on here, hit peak use samples, and there they are. I haven't color-coded this yet, it's just black dots, but we can style it to represent it a different way. Perhaps I want to generate a quick section through those. so I can quickly look at how does it fit in with the geology around the area. And now you can just see those where the peat is applying and where the information is coming in. So it's a way of viewing and understanding your data, analysing it very quickly once you've got this data stored centrally in a centred database. Oh, my throat's going up here as it's giving out here. So going on. So that's one way. The other thing that we'd like to do is make your data available. We've got this data in the central BIM model as such within HoleBASE. What you want to start doing now is using it in tools that you're familiar with. Now, most engineers, they're only normally happy with software when they're working in Microsoft Excel. So let's make this data available in Excel. So again, another little quick presentation. We're inside Excel here, and we're clicking on the HoleBASE, and you can see it's asking us to log in again. So we're logging into HoleBASE. I don't need HoleBASE on my local machine, just as long as I can click on get to the HoleBASE database on the network somewhere. I'll go to my test project again, and in comes the connection through to it. And what it's asking me now is which of these reports that we've got loaded into my test project. So these are all saved within my actual project on the central database. Do I want to run? So I've just gone for one called the grading envelope here. And ready for this? Generate. So as I click the generate button, it's gone through to the HoleBASE database and it's pulled that information into Excel. So this is for boulder clay. So we now have got our particle size distribution for the whole of our site being shown for boulder clay. And like for glacier till, that was just done with that simple click of the button. There's a way of making your data available for use and reuse time and time again. So we're going to do the same thing here again, and this time, just to give you an idea of the concept of how this works, I've got one here called Geology Dashboard. So these are just Excel templates that you can create and modify yourselves that we've created just to give you an idea. And by clicking that generate button then, we have now, for the whole of our site, a whole host of different quick graphs showing you all about what's going on around your site. Antiberg A-line, moisture content, plastic limits, all being generated on the fly, pulling that data through. And again, it's because you have that central data model that we're using time and time again. So really coming more to the conclusion now, the last tool we want to access and use this information is now inside AutoCAD Civil 3D. And again, it's the same principles what we're talking about here. We're inside AutoCAD Civil 3D. We click on Connect, and up pops a dialog box. We're connecting through to the same database yet again. I'll give it my initials, my details. It's connecting through. Which project do we want to work on? I want to work on my test project again. So now it's putting that initial data through into AutoCAD Civil, and you can see in those few seconds it's actually created me my 3D boreholes. Now I've done this in a blank drawing. Normally you want to do this with a site plan with some mapping on there, but I've just done this for speed in a blank drawing. You've got an inclined borehole there, but we can now see where our 3D boreholes are, what's going on around our site. Now this is the location manager, and in here we can control how we want to look at our locations, which ones we want to show. Here we're changing the vertical exaggeration. If I want to band it by legend codes, or I haven't got this configured yet, but say USCS, Unified Soil Classifications, we can band by those, work out what we want to show, what we don't want to show, turning off and on different elements. It's all controlled in here. But where things get a bit more fun is when we start going to the strata manager. So these now are all of my different strata I've got in this project. And as I click, it's actually creating AutoCAD Civil 3D surfaces for us. So all I'm doing is clicking now, and there's the surface created for me. And it's basically joining the dots together in our boring logs, so the different strata values. It's joining the dots up. Now, this is not a perfect geological model. It's a starter. And in future webinars, we can show you how you can model this data using things like Autodesk feature lines and break lines to actually model it. At the moment, we've got a starting point to give you an idea and give you an indication of what geology is around your site. but it really does help eliminate problems. But we can generate surfaces not only just on geology, but on any data that we have inside our database. So for instance, our SPT blow counts again, let's say we want to use that. But what we want to do is map out where we've got soft ground around the whole site. So let's come on here and we'll go down to our M values again. Because we're looking at soft ground, I'm interested in the minimum value that we have down the hole. So we'll go finish, and it creates an AutoCAD Civil 3D surface. Not too useful looking like that. So let's just change the properties to a banding method. And now you can see we've got a map generated, and this orange area is where we've got soft ground. Now we can do that with any data we've got inside HoleBASE. As long as it's managed correctly, we can use this and view it. Another thing we could do is, okay, let's start creating some quick sections or profiles through this data. So again, we just turn on our surfaces again, and we'll come up to the HoleBASE create profile command, and I'll come in here, and what I'll do is I'll tell it to create an alignment for myself. So we'll just click, tell it where we want to draw this alignment through. We quite often call these things long sections, actually. I think it describes it a little bit better, so we'll draw those through. We can decide whether we want to hatch. Now, I didn't create top and base for all of my different geology, but if I had, I could then hatch the whole lot if I wanted to. I'm just hatching one here just to show you. Pick which type of profile, log profile I want to show. Log strip I want to show on my profile. These are all user definable. You can create your own. So we've got ones there showing water strike levels based on what we call our legend code. We can geology code. It could be showing USCS values. These are just standard AutoCAD profiles, so we can use normal AutoCAD profile commands to modify those. I've just tried modifying that. I haven't quite made the base long enough so my borehole overlaps, so I could change that again. But you can see really quickly we've generated these sections, we've pulled the information through, we're making full use of AutoCAD Dynamics profiles, so you can just see it's a great thinking tool to work out what geology is going on around your site. Here you can see we've got these sort of multi-overlaid hatch patterns, depending on which methods you're using to represent your data. You know, standard AutoCAD hatching may not be sophisticated enough for you. So here, for instance, we have a whole series of hatch manager in here, and we go down, we've got clay, silted, cobbly, gravel. We make that up from 4 different hatch patterns. It's all completely user-definable. You can pack whatever you want on it. Here we're saying what styles we want to represent our strips by, what symbols should we use on the map, on the plan, how should it look down the hole. Again, it's all configurable from here. And what we're basically saying here, again, is if you're actually managing your data, if you're using data as opposed to sending lectures PDF backwards and forwards, you can start looking at this data, you can start visualizing it and sharing it with people. You can collaborate. You know, one thing I haven't had a chance to show you here now, but in the latest release of AutoCAD Civil, there is the productivity pack, which you can generate solids. So if we create a surface for the top and base of my geology, in 1 or 2 seconds, you can convert that into an AutoCAD solid. That's great then for taking out into Navisworks, into Revit, and putting into other systems. And it's all based around having a proper geotechnical data, which you can model and use essentially, and then you can share it and make use of it in many different places. So what we're really talking about here is the geotechnical industry, if it applies the right approach to this, can really make full use of BIM. You know, applying BIM principles to geotechnics is straightforward if you just think about it. And if you do it, we can't guarantee that you'll reduce all your underground conditions, but hopefully you will be able to reduce some of these things and actually make some significant savings. So I hope that's sort of giving you a good indication, a very rapid tour of what we do, but hopefully if you need any more information or want to see this, then please respond back to Microsol's questionnaire and we can give you some demos and give you more information in the future.